Okay, we're now recording, so I want to welcome everyone to the composting session for our Southeast District gardening series. I want to introduce our two speakers for this morning's session. One is Simon Kafari. Simon is the extension educator in Clark County, and our other speaker today will be John Hawley. John is the extension educator in Dearborn County. So, gentlemen, I will turn it over to you.
Yeah, thanks, Carl. Let me stop my video because I have very unreliable internet. So this probably will help to minimize any problems. Let me share. Are you guys seeing my slides?
Looking good, Simon.
Okay, good. Yeah, thanks again for coming. This morning we'll be discussing a very familiar topic to all of us, and that is composting. I always start by acknowledging some of the sources where we get this information from, because as extension, it is important for you to be grateful to people who have done research and you are using some of their information. So very quickly, let's go through the overview as to what is going to be covered this morning. We will quickly take a look at what composting is. We will also look at why composting is important. I know, you guys already know the importance of compost, but we'll just briefly touch on its importance. And then we'll look at the composting process and the factors that influence the process. And then take a look at curing of compost. I know most of us at home will normally think that curing of compost is not an important part of the process, but we'll touch on why it is important for you to cure your compost before you use it. And then finally, we'll take you through the different ways by which you can use your compost when it is ready for use. So what is composting? The other day, I took a very cursory look at Amazon.com, and if you put composting into Amazon.com, you are likely to come up with probably close to 9,000 books with the subject. That tells you how popular composting is. The process occurs, as you all know, naturally. It also occurs in landfills and at homes, and it is well known all over the globe. Composting is a natural process of recycling organic matter such as leaves, food scraps into valuable fertilizer that can enrich soil and plants. This is taken from Natural Resource Defense Council, and that is what their definition of composting is. I thought I should just quickly put it here for us to have a definition of what composting is. It is a very inexpensive way to garden and to eat healthy, because you create compost and not have to buy compost from some of these places like Walmart, which could be contaminated with other material. You make your own, and it is inexpensive, as I said, because looking at the picture on the right-hand side, this is actually the compost that I have in my home. Those bags, those unwoven breathable bags, I bought them on Amazon.com for $15. I bought 5 of them for $15. And one of them is actually reserved for the turning of the compost. So each time I'm going to turn my compost, I bring that empty one, turn the compost from one of the bags into the empty one, and then I continue till I finished all 4. And these 4 are more than enough for me in my, to use in my garden. I'm even thinking that I'll expand the process next year so that I can have some for my lawn as well. So it's really very inexpensive. It is a biological process. It involves the biological decomposition of organic matter. It occurs daily with or without human intervention. It occurs naturally in the forest. It occurs with our intervention either as a means to recycle or to use organic material for our gardens. The process is fairly simple. The sad part of it is that as simple and as rewarding as it is, we often get it wrong. And that is why we have this class this morning to help us understand the processes that are required, not only to accelerate the composting process, but to also ensure that you come out with a high quality compost. The location of the compost pile is not doesn't influence the process, but it is equally important. And I thought we should mention it here that the ideal location for a compost pile is a dry, shady spot. This will minimize the drying out of the compost and will minimize the need to frequently add water to the compost pile, because the more frequent water is added, you reduce the temperature and the cost of doing that, and that affects the process. So it is always important to avoid placing it in places such as under eaves, where the drainage is poor, and you are likely to get your compost soggy or very wet. So why is composting important? Let's briefly look at the importance of compost. Let me start with the improvement of soil health and how compost helps to lessen erosion. This is done in research, and there's a lot of body of research that has confirmed over the years that composting is important in improving soil health and minimizes soil erosion. It's an essential ingredient, as you know, for the food that our plants eat in or take in whether it is in the garden or in our lawns, because in compost you have the 3 major nutrients, NPK, that is nitrogen, phosphorus, and potassium. It also has minor nutrients such as calcium, magnesium, iron, and zinc, as well as its ability to increase the cation exchange capacity of your soil. Instead of us relying on synthetic fertilizer, especially when you are a gardener, it is recommended or advised that we rather use compost, which has minimal harmful chemical effects. The use of compost offers another way to minimize soil erosion, as it, compost absorbs and keeps a lot of water within the soil structure and minimizes surface runoffs that causes erosion. So let's very quickly take a look at the role of compost in conserving water in the soil. Again, there's a large body of research in this area, but one statistic I just want to point out, which is very relevant, is that 1% increase in soil organic matter helps hold up to 20,000 gallons of water per acre. That is huge. So the use of compost in your garden actually conserves water, and when there's a drought, your crop is resilient because you are able to maintain this high level of moisture content in the soil. How about temperature? We all know that roots actually will normally need a reasonable range of temperature within which to do well as microorganisms. So the use of organic matter or the use of compost helps to moderate the temperature range within your soil. Temperature moderation provides a conducive environment for plant roots and what it also does is that it increases not only the number of microorganisms in the soil, but it also promotes diversity of microorganisms. One other area that I thought we should touch very quickly on is the issue of methane emission, which is caused, is emitted a lot in landfills. We are all very familiar with the greenhouse effect, the warming of the environment, and the rise of sea levels. 16% of greenhouse gases is methane and 56% is carbon dioxide. Both of these gases are greenhouse gases. But the bigger problem of methane that I am emphasizing here is that 28 to 36 times, methane has 28 to 26 times more effective than carbon dioxide at trapping heat in the atmosphere over a century. So with as much as we have more carbon dioxide produced during composting, methane has more impact when it comes to heating up the atmosphere. And that is where it is important for us to know that the more composting that we engage in, the less material that we send to landfills, the less methane that we'll have, and that will help minimize the heating of the Earth atmosphere. When organic waste goes to landfills, we all know what happens. We heap anything that we get in the landfills, including plastics, including organic matter. What this does is that it reduces the carbon oxygen level in the landfill, and a reduction in oxygen level leads to anaerobic decomposition. And it is a lot of the anaerobic decomposition is what brings about an increase in methane production. What we normally see, the gas we normally see, which is called biogas, is normally about 50% methane and 50% carbon dioxide. So you can imagine what you will do by composting your home waste by way of reducing the methane that is produced in landfills. In the US alone, landfills are a third largest source of human-generated methane emission. That further emphasizes why, helping to reduce methane production in landfills by composting is really a very important thing in our country. One thing that we are all very familiar with, and that most of us engage in composting for, is to reduce the waste stream that we generate in our homes. Plants and animals that die need to be cleaned, and household waste that we generate at home also needs to be disposed of. In the US, an average of 230 pounds of yard waste is generated per person per year, and an average of 100 pounds food waste is generated per person per year. That is quite large. These large amounts of waste that is generated is better for us to be able to compost them rather than send them to landfills where methane will be produced. Natural composting helps to rid the earth of some of the dead plants and animals. Consumption of these dead plants and animals by mammals, birds, rodents, insects, and worms helps to clean our environment. It is nature's way of helping us keep our environment clean. But human composting is becoming a very key part of why, of helping to keep our environment clean, of helping to reduce methane production. And that is our own way that we can help to minimize the environmental impacts that waste cause to our environment. Human composting, by encouraging it at home, communities are able to reduce environmental problems associated with municipal waste. We are also able to reduce costs, especially those who live in cities. You pay for the waste that you get rid of. So you are able to reduce costs associated with municipal garbage and trash removal. You are also able to minimize on pollution and contamination of water bodies. And by engaging in composting, we are able to get rid of some of these deadly and dead animals and smelly environments that would have been created otherwise. But the other good thing about composting, as we all know, is that we can turn something that would have gone to waste into something useful, and also help sustain our environment for future generations. So let's switch gears very quickly and go into the composting process. On the screen, you have a very simple composting equation, which says your yard waste or your food waste is added to water and oxygen, and microbial activities generates an end product. The microorganisms decompose yard and food waste, but they do this not because they want to give us an end product called compost for our gardens. They do this because that is what they need to exist. They need carbon for energy, they need nitrogen for protein. And the way they get those is to attack organic matter. And with the right organic matter, that is the carbon nitrogen, a proper carbon nitrogen balance, which I'll discuss a bit later, and a conducive environment, microorganisms are able to provide a livelihood for themselves. And in the process, they give us the compost that we need for our gardens and our lawns. To be able to convert organic matter into energy and protein, the microorganisms will also normally need water and the right amount of water and air. And the unintended end products which are compost, water, carbon dioxide, and heat is as a result of the microorganisms looking for their own livelihood. The heat produced during the process normally will start at ambient temperature or room temperature, and it can go as high as 160 degrees Fahrenheit. The increased temperature results in increased water evaporation. And that is why when you go to a commercial compost making site, you will see a lot of vapor coming out, that as a result of the increased discharge of water vapor. And that is caused by increased temperature within the compost. As the process nears completion, the temperature goes back down to about room temperature. The end result is a material that is reduced in weight and volume, and it is normally brownish gray looking. The fact that we are able to hold compost is because some of the organic matter that is in it, and which is difficult to completely decompose, that is what gives us the structure that we are able to hold the compost when it is fully done. So let's quickly look at factors that influence the composting process. Knowledge of those factors will normally are very important for you to know to help us produce not only a quality compost, but to speed up the process as well. There are four main factors that I want us to look at this morning. The first is the type of decomposers and their numbers, microorganisms and vertebrates, and the diversity in these microorganisms. We will also take a look at the type of organic material and their composition. And by that, I mean the greens and the browns that are involved in our composting process. And we'll take a look at the internal environment of the compost pile. And we'll specifically look at air, water, temperature, and pH. And then we'll take a look at the composting methods that are commonly used. We'll take a look at three composting methods: the aerobic, anaerobic, and bag composting methods that will give you a variety of methods that you decide on which one is best for you to use at home. The types, numbers, and diversity of composters. One thing is, which is important for us to realize to know, is that all of these decomposers are heterotrophic. In other words, they use organic material to generate energy and protein, as I mentioned earlier on. For a good composting process, you normally need large numbers of microorganisms. The higher the number of decomposers attacking the organic matter, the faster the process will be. But in addition to that, you also need to retain a diverse decomposers. That means you need to retain different types of microorganisms that will be able to survive under different conditions. So you need aerobic and anaerobic bacteria. You also need invertebrates. It is always important to bear in mind that in addition to the increased number of microorganisms that you want to attract to your compost pile, you are also looking or aiming at attracting diverse population of these microorganisms. The two together is what is important for your decomposing process. The different decomposers normally prefer different organic material and different environments. So you have some decomposers that are able to attack lignin, that is the material that gives the leaves and the stems their structure. You have decomposers that are able to survive in extreme temperatures. Others are able to survive with limited air. So you need to have a wide range of organic material and a wide range of environmental conditions, different environmental conditions that will favor these different decomposers. During the process, you have millions of different decomposers get engaged in various stages of the process. So diversity is always key. The more diverse the decomposers are, the better it is for the process, because if depending on whether the temperature is high or low, you have different decomposers operating at those different temperature extremes. And depending on whether you have a high or low pH in your compost pile, you will need different decomposers, or different decomposers are able to operate well in different pHs. And again, depending on whether your compost pile has got high moisture or low moisture, you will normally attract different decomposers. What this is that I'm emphasizing on the fact that in addition to the numbers, the diversity of decomposers is really very important to aim for when you are setting up a compost pile. Key elements in organic matter that used by decomposers are carbon and nitrogen, as I mentioned earlier on. Carbon for energy and nitrogen for the protein. Nitrogen provides microbes with the protein, and when you are looking to provide nitrogen in your compost pile, what you should be aiming at is to provide adequate amount of greens in your compost pile. You have on the screen, I just listed a few examples of greens or materials that are good green materials that you put in your compost piles. These will include fresh grass clippings, fresh manure, kitchen scraps, weeds, and green leaves, leftover fruits from your garden. But you also need, as I mentioned, greens, which are providing carbon for the microbes to have energy. And very good examples of greens are brown and dry leaves, dried grass, straw, corn stalks, sawdust, wood chips. I think what I normally emphasize here is that whatever greens and whatever browns you have, it is always better to accelerate the process. It's always better for you to shred them or cut them into smaller pieces if you have the time to do so. To produce a good quality compost, you need the ratio of your browns, that is your carbon, and your greens, that is your nitrogen, to be properly balanced. This is normally referred to as a CN ratio in composting. The right combination of the browns and the greens in your compost pile should be about 25 to 30 parts of your brown to 1 part of your greens. So if you, at the end of the fall, when you are collecting your brown leaves that are falling from your tree, and you want to put up a compost pile, what it says here is that if you collect 25 buckets, 25 to 30 buckets of your leaves, what you need to do is you need to get greens, 1 bucket of greens to add to them in order to balance, to provide a balanced C/N ratio for a proper process in your compost pile. A good C/N ratio will normally help absorb excess moisture in case you have too much water in your compost. It will also help maintain the needed air pockets that the microorganisms will need to be able to operate well. And it also promotes diversity if you have a good balance of the carbon and nitrogen ratio in your compost material. Remember that too much brown is not the major problem. The process will delay. In some cases, you will even have the material decay, but very often you will probably come out with a compost material. It may not be of high quality, but you will still come out with a compost material if you have a lot of browns or only browns. What you need to do is to frequently turn your compost pile so that you can increase aeration. And if you get a chance, you have greens, you add some greens to your browns, and you still normally come out with an end product. The biggest problem is if you have too much of greens, or if you have greens alone, like your kitchen waste. What happens is that the composting process will normally start rapidly to start with, and very soon it will stop. And what you quickly realize is that you have this matted, smelly, soggy mess. And very often you have people say, I started my compost pile and it is so smelly, or the people in the neighborhood have come to me and they are complaining that my compost pile is smelling. It's because you have a lot of greens and very little browns in your compost pile. The place of home composting has become so important even at the national level that these days, if you go to the Environmental Protection Council website, they have a list of products or items that can go into your home compost and what should not go into your home compost. So if you are going to start a compost pile and you are new to it, one of the places I recommend is for you to go to the site of Environmental Protection Council and get a guidance as to what works very well when you are doing a home compost. Now let's very quickly take a look at the internal environment for the compost pile. Again, as I mentioned earlier on, we'll take a look at the water, air, temperature, and pH. Let's take a look at water and air. Both aerobic and anaerobic composting need water and air. Anaerobic composting normally require reduced oxygen, but most of the composting that we have we see at homes is the aerobic composting, which takes a high level of oxygen. Aerobic composting needs oxygen concentration of about 18% to function well. The ideal moisture content in a home compost pile is between 50 to 60% of moisture. Compost with the correct amount of moisture should feel like it's a spongy material. If you hold it in your arm, it feels like it's spongy. But if you realize that your compost material is not spongy or it has got less water, what you do is you add water. If you realize it is getting too soggy, the best is to turn it frequently and air dry it so as to get back to the moisture content that is good for microbial activity. A proper balance of water and air is required by microbes to thrive and continue decomposing your organic material. Too much of moisture, of course, normally will fill the air spaces and drive out whatever oxygen is required in the compost pile for anaerobic decomposition. On the other hand, too little moisture can also slow down the process. So it is always important to be mindful of the proper balance of moisture in your compost pile. You provide adequate air by turning the pile from time to time. And the more frequent the turning, the more air is provided to your pile. One thing that you should note is that you have to be careful when you are turning so that you don't overturn, because too much turning can significantly reduce the internal temperature of the compost pile and slow down the process. And too much turning too can also lead to the compost getting dry. That will require the use of water. And the more water you spray on your compost pile, the temperature reduces, and that affects the speed or the acceleration of the process. How about temperature? How does temperature influence the composting process? One thing you should know is that at a temperature of about 40 degrees centigrade and above, bacteria become active. Less than 55 degrees reduces microbial activity and slows the process. In other words, although they will start become active at a temperature of 40 degrees Fahrenheit, anything less than 55 degrees Fahrenheit still slows down the process. Once the temperature gets to 70 degrees Fahrenheit, that is when microbial activities will kick into top gear, up to 100 degrees Fahrenheit. From a temperature of 70 degrees Fahrenheit, microbial population will normally double with every 10 degrees Fahrenheit increase in temperature up to 160 degrees Fahrenheit. So you see the temperature is really very important when it comes to producing compost at home. One way to prevent low temperature is to ensure the pile is light. And the recommendation is that you should have at least 27 cubic foot of compost structure, and that is 3 feet per side, and no more than 4 to 6 feet tall. This will help insulate the interior so that you have adequate heat generated to promote the acceleration of microbial activity that you normally would want inside your pile. Generally, the high heat does not hinder microbial activities in your pile. It is important for you to note that even at a temperature of up to 113 degrees Fahrenheit, there are certain microbial microbes that will not even survive if it is a temperature lower than that. So some microbes will survive or do better at a temperature of 113 to 158 degrees Fahrenheit. So the higher the temperature, the more diverse the microbes are. Turn compost frequently when the temperature is too high, and especially when it is in the summer and you have frequent high temperatures, it is always important for you to turn your compost. pH also plays a very important role in the composting process. And I want us to quickly take a look at how pH influences our composting process. pH is important in the sense that it, at a lower pH, that is when the pH is acid, certain microbial activities that break down lignin are the ones that operate well at that level. So, and at a very high pH too, there are certain microbial activities that do not operate very well. So a good pH for operation is a pH of neutral to slightly in an acidic environment is what you need in your compost pile. Early in the composting process, organic acids are formed. Yeah, that is what I just mentioned. The acid condition promotes the growth of fungi and breakdown of lignin and cellulose. As the composting process progresses, the organic acids then get neutralized. And once the acids neutralize, those decomposers that attack the lignin and cellulose, they reduce in numbers. And those decomposers that are going to attack the rest of the organic matter are encouraged, and they increase in numbers and in activity. A pH range of 6 to 8 is required for the process to function well. There is a sharp drop off in activity with pH dropping below 6. That is an acidic pH. If you realize that your pH, the pH in your compost pile is dropping too low, below 6, below a pH of 6, it is normally recommended that you add wood ash to maintain a pH that is, close to neutral. Having gone through what what composting is, having taken a quick look at the importance of the composting process, and also a little bit of the composting process and the factors that influence the composting process, I will hand over to John so that he will continue and he will get into the details of the common methods that are used in the composting process. So the other two things that I should mention is that John will also look at the curing of composting, as I mentioned earlier on, and how to use your compost when it is ready. So I will unshare now and hand over to John to take it from here.
Thank you, Simon. I really appreciate that, and appreciate you setting up the first part of the presentation here. So I'll go ahead and share, and we'll get right back where we were. Let me know if y'all can't see that. Do we look good?
Yep.
Perfect. Well, as Simon mentioned, my name is John Hawley here in Dearborn County, Indiana. We'll finish up today, as Simon said, with both the curing of compost and the importance of that process, how necessary it is to actually have an effective compost to use, as well as traditional and more innovative methods. You'll actually see a picture right there. We'll talk about creating compost tea, as well as some other methods. So there's essentially three different methods of composting we're going to talk about, and some you're going to recognize the more traditional methods, if you want to use that phrase, as well as some more innovative methods of composting. So there's the cold method. This is essentially what goes on in the environment as it is. Simon sort of mentioned this. We have composting going on in the woodland floor at all times of the year. So this is a natural process. Really any type of forest floor, whether it's, the North American climate, South American, wherever you are, materials are being composted. I believe the term is littoral zone. So essentially that's the first few top layers or the first top layer of the soil in the forest floor, with your seasonal leaves and your limbs and your tree branches mixing with, water from, obviously rain, flooding events, as well as animal waste. These processes in a lot of ways evolved and grew and worked in tandem with animal grazing, things like that, hooves shoving and turning a lot of the leaves. But really, oftentimes it's just breaking down slowly with the microbes and other organisms in the soil. So to do this on your own, actually to replicate essentially the process that nature's already taking on, this is actually a process that was popularized in India. It's probably the least labor intensive process, but it's going to take longer than other methods of composting. And also you're kind of cutting your range of microorganisms that are, working to help you with this process, because since you're not creating a traditional compost situation, it's not going to heat up quite as normally as it might. But essentially it's a very efficient process if you're willing to work on it and be patient. So more about the cold method. Slower, as I've already mentioned, but that's because the environment isn't as ideal as our traditional methods of composting. The temperatures are going to stay lower. Simon's already talked about it. And a lot of folks, when I tell them about composting and it's something they haven't tried before, I tell them that temperatures can approach or exceed 150, 160 degrees, and that's an ideal range in traditional composting. It just blows their mind how that can happen, and how the microbes and the environment take a part in that. Well, in the cold method, we're not getting anywhere near those temperatures. And so you're not going to get as many of those, aerobic microbes. It's going to take longer to get that finished compost product. But like I said, it's less labor intensive, and kind of like the diagram here is showing, or these pictures are showing, you can continually add materials without being quite as concerned with turning and things like that. And like I said, a lot of folks, if you're patient, it's a neat method to try. A lot of folks have tried different methods of composting. I will give you a full disclaimer. I have not done the cold method myself. But we'll talk about how you really only need to turn the pile 3 times to fit this method that cold method. So there are some recipes, and Simon kind of already touched on this. You know, not every compost recipe is perfect, but if you are generally within this range, or you follow these sort of principles that are, you know, research tested and peer reviewed, you're going to be better off than just going at it on your own and throwing everything in and hoping it works. So the recipe for the cold method would be looking at a pile that's about 8 or so feet per side, and you're layering it up. The bottom layer, you start with twigs and brush, more of an open, you know, base to allow air to move in and flow. And we're going to talk about the problem with compaction here in just a second, because you don't want to run into that issue. Starting with those twigs and brush at the bottom is helpful. Then you want to go into those dry browns that we talked about a little bit earlier for, you know, about 6-inch layer. 2 inches of more green material on the top. So those fresher materials we talked about, coffee grounds, you know, are one example. And then you can go with a thin layer of actual soil on the top, whether that's a native soil or something else that you're adding. And that's actually going to be kind of your recipe for adding the microorganisms, the microbes to the pile. And so you can run, you saw the picture on the last slide, roughly a 4 to 6 foot pile for this cold method. And you'll continually add, you know, you don't want to get a pile that's, you know, 6-7+ foot tall. That's going to be too tall. You're going to want to work with a manageable pile, you know, perhaps around 5 feet at max, because as I mentioned a second ago, compaction can be an issue. You want to be able to have airflow. We'll talk about it here in a second, but with this method, you can also use, you know, the back of a shovel or something cylindrical in shape and actually poke holes to allow air to move through these piles. So why would you even consider this method? You know, and I've done a lot of traditional compost piles in my time where I'm turning regularly, and I've seen the benefit of that over time. But why would I consider this method as a gardener? Well, the care is going to be minimal. It's less intensive. So maybe you just don't have as much time. You've got other projects around the house, around your farm, wherever you are. You can really focus on about 3 times turning the pile. After 15 days, after 30 days, and then 1 month after that. And that may be all the turning you really need with this method. I mentioned it a second ago. You can ventilate the pile by using a pole, roughly 5 inches in diameter. That's, you know, if you have something else around, maybe the back of a shovel, anything that's going to allow airflow to get in there would be helpful. And luckily, you know, you're looking at about 12 weeks to have a potentially usable compost. We'll talk about how to actually realize if your compost is ready or not here in just a minute, because you know, that's all important, as well as the curing process. But you know, that's your determination, understanding when that fresh material is broken down enough and ready. And then if you're constantly adding fresh materials, you know, obviously it's going to be more you know, ready to use at the bottom than it would be at the top with the more recently added materials. So you can harvest from the bottom and then start over as the process moves along. So another composting method, moving on from the cold method, this is the hot or aerobic method. So we're going to be citing the University of California here. You can see a diagram right there that kind of shows the different layers. So similar to the cold method as well, you're going to start with a base, or it's helpful to start with a base of brush or twigs to improve the airflow. You can add dry matter like leaves, wet matter like greens, and continue stacking from there, adding that soil or manure to let those microbes and organisms begin to do their work. Dry layers of leaves, you know, wet layers of greens again, and then start over in roughly 3 by 3 piles. This is kind of a standard method, if you want to say it like that. Everyone does it a little differently. I've seen piles and hot composting methods of all different sizes. But as Simon talked about a minute ago, the right balance is important. If you have too many browns, it may not break down as efficiently. You may still get a good compost, but you want to have a good mix of those nutrients. And so that's why this diagram, these layered diagrams will be helpful. And for those that feel like they may forget that, you know, be reminded that we're recording this session right now. So we'll have this uploaded within a week or so, and you can always come back to refer to that. But the goal is to create with this hot method, you know, it's the environment's hot and high in oxygen. Microbes are working with enough air, and that's going to help speed the process, move it along. And so I've already talked about it. Start with the layer of brush, alternate the layers, no more than about 6 inches or so a piece, with the browns and greens going back and forth, alternating. And then once again, you're adding that soil or perhaps a manure to get the natural process moving along. That right balance of browns and greens is important with any compost pile. And then also correctly turning it, actually getting it moved. You know, sometimes these piles can start to compact and get real thick. And if it's gotten too wet, it can be quite heavy to turn. So that's why turning as efficiently as possible is important. And in this case, once a day is going to be recommended. You know, it doesn't mean that, you know, if you miss one day, the pile's ruined, but just stay on top of it. Don't let it, you know, get on the back burner. And then of course, you know, we may get to those typical Indiana summers where all of a sudden we hit June and it stops raining. You can add water if your pile gets too dry. That continues to let the process, the microbes and everything living within that pile continue to break down. And then you can, you know, put leaves on the top layer after each turn. That's going to kind of insulate the pile in a sense. And like I said, for those that are newer to gardening or haven't tried composting before, you will be surprised the heat that just comes off of that pile when you're working it or even standing near it, you know, in a sense, especially with the kind of heat we get in our Indiana summers. So we mentioned earlier, you know, temps can be as high as 160 degrees. And that's actually, you know, what we're looking for. That high temperature gets the process going. Another really important factor that's going to kill most of your weed seeds and most of the weeds in general. Now, it's not going to get everything. I tell you, every compost pile I've seen has got something growing out of it. I even work with a group here in Lawrenceburg, Indiana, that has mentioned that they've had some of the best tomatoes growing out of the side of one of their compost piles. So it's not going to kill everything, even if you do it exactly right, but it's going to help you get a lot of those weeds broken down. And that's going to, you know, focus on benefiting the microbes. Your worms and your beneficial insects in the ground aren't necessarily going to be in that pile until it cools down later on when it's being used. But as Simon mentioned earlier, that carbon to nitrogen balance is important, you know, for the process in general, and maintaining it properly is how we get it to a cured state, which we will talk about here shortly. So let's go to the compost in a bag method. This is a little more useful for somebody with limited space, perhaps somebody new to composting, somebody in an urban area. Really, a lot of folks do this sort of method, you know, in a box underneath their kitchen sink. I don't know about if anyone else here has cats or anywhere that has buckets handy. I buy our cat litter for our house in these sturdy 40-pound buckets. You know, they hold 40 pounds of litter. And I've composted in those before. I've seen a lot of other folks that'll put it underneath the sink or maybe in the sunroom or storage room, and they'll put their greens, their browns in there, and they'll turn it and mix it as needed. You know, you could essentially put a compost bag like this in this method within that bucket, or somewhere handy. If you're like me, you have a young kid in the house, somewhere that your you know, kid isn't going to get into. So ideal for limited space. Use a heavy duty bag though, because when you are ready to use the materials, they're not going to be light. You don't want to have a compost go all over the floor in your kitchen. And essentially it's kind of a mix between, you know, like Simon talked about earlier, the aerobic and anaerobic composting. It's not quite as efficient because you're putting this compost in an alternate, a non-natural environment. So you're going to be moving and turning and crunching the bag, and you know, maybe you can use a stick or an old wooden spoon that's no good anymore, and mix it a bit as needed. I'm not telling you to do it every hour or something like that, but you know, it's a quick method. However, you may have a cured compost that could be ready to add to the garden or to your landscape beds within 4 to 6 weeks. So what's a typical recipe for this sort of process? Pretty simple. You know, kind of use the ratio of, you know, 1 tablespoon or so of green materials, a half a cup of soil, 1 cup of your dry brown materials, you know, maybe those dried, you know, leaf clippings or grass clippings, I should say. And then make sure you've got enough water in there. You don't necessarily, I mean, you know, you could put just an ounce of water in, but if it seems moist enough, you probably will be okay. And you're going to keep adding until the bag is nearly full. And that's when you know, you want to keep an eye, make sure it's curing, which I promise you we're going to talk about here in just a second. And then tie it up loosely, but you don't necessarily have to, you know, seal it off or anything. Like I said, you know, you could put it in a bucket somewhere a little safer out of place. Simon talked about smells earlier. Composts always have smells when they're curing and getting ready to be worked. You may put some eggshells or something in that. So, you know, there may be some moderate odor, but if you put it in some sort of bucket, you're obviously going to reduce that sort of problem or somewhere out of the way. And then, like I was mentioning earlier, you can squeeze the bag daily, mix it up, maybe use an old spoon. Make sure you're peeking in there to check it's not drying out too bad. If it's too wet, I do the same thing with my soil samples I help clients with here at the office. I open up that bag, let that soil, or in this case, the compost, get some air to it, let it dry it out. And if not, you can take a squirt bottle or maybe just a little bit of water, dump it in there, and then make sure it's kind of a spongy feel at all times. Compost is a natural thing in the environment like we talk about, or like we've already talked about. So think of it kind of as when you go out in the woods somewhere, it's a nice spongy feel. That's what you want your compost to feel like. We've talked a lot about turning compost. What are some of the tips for turning it, and how frequently should you do it? Obviously, we talked about some methods, it's only a few times. Other methods you should be turning every day, especially as you're adding more and more materials. The inside of your compost pile, especially if you've got a pretty full pile going, that's where that heat is going to come from that I was talking about. It's also where the microbes and all the natural organisms are starting to break things down and starting to process, if you want to use that term, your compost. The outside of your pile is kind of like a shell, drier, less active, much cooler. So you're going to actually turn and use a rake or a tine to kind of move those things around, let the pile start to break down, turn it over physically. Bring that food and water from inside the core to the microbes on the outside, and just turn to properly mix your ingredients, the browns and the greens, so there's not a whole bunch of browns on the top, not a whole bunch of greens on the bottom. Mix that up real good. That's going to actually speed up and put your decomposition process in the right phase, and then turn to air dry if the pile's a little too wet. So I know we're getting a little close on time here. I'm going to try not to go too fast, but curing the compost is absolutely critical, like we were mentioning a second ago. It's not finished. It's not ready to put in your garden or in your landscape or wherever you're using it until it's cured. That's something that a lot of folks may not realize. You want to see a broken down, almost soil-like, not necessarily like a typical soil you'd see if you went to Lowe's and bought a bag, but you want it almost kind of soil-like. You don't want to see big twigs and whole pieces of, maybe you cut up banana in the pile or eggshells. These things should be pretty well broken down by the time you're using the compost. This process, as far as actually letting it cure, can take up to a month and a half or so, just kind of depending on how big your pile is, what your inputs were. And that's actually going to allow the microbial activity to reduce to a level that may not pose any threats to plants. It can be cured directly in the composter, in a pile, or transferred to somewhere, kind of like you see in the pictures here, for that process to take place. You're done turning at this point. You're not going to continually turn it. You're going to let it rest. You're going to let it cure. Doesn't mean you can't poke in there and look around and see how things are going, but don't feel like you need to continually turn it every day like you were. And that's, really because, the microbes in the environment, actually curing it itself, the process, that's what's taking place. So it's not as intensive for you as the gardener. And that really stabilizes it, makes it in a more usable form. Like I said, if you pull out compost too early, it's going to be full of stuff that it's whole eggshells and coffee grounds and materials that aren't broken down enough, leaves and things like that you've added. So you want to make sure that those, are properly broken down. And that the temperatures in those piles, since you're not turning it, since the process is slowing down, it's not going to be as high. There's not going to be as much activity taking place. So what does a finished product look like necessarily? It's going to kind of have that, like I said, not quite like a soil you go to the store and buy, but it's going to exhibit a few of the following, physical attributes and internal attributes. So it's not going to be hot anymore. It should have little to no discernible plant material. You're still going to see chunks of things in there. It should be kind of crumbly. It should be generally darker, brownish or so in color. And the comparison that we're using here is maybe chocolate cake-like. And it shouldn't smell bad. If your compost still has some sort of off odor, maybe kind of ammonia type or something just kind of stinky in general, you may have added a little too much of something. It may not be properly cured yet. You may want to let it sit for a little bit longer and continue to cure. So how do we actually put our compost to use as we get to the end of the presentation here? How do we actually take that properly created and cured compost? How do we actually add it in? What's the right time? What's the wrong time? So spring is obviously when everyone else is gardening and you're working not only in vegetable gardens, but in your landscapes and your lawns like I am. You can add it directly to a lawn. You don't want to add too much, obviously, because then you may create mud, but you could do 1 part compost to 2 part topsoil every year for growing or renovating a lawn. In an established lawn, you can actually do a very thin layer, spread it out. And you see the picture right there of the gentleman kind of raking it into an existing lawn. Think of that as kind of an alternative fertilizer per se. It may not necessarily, if we've got any lawn geeks on the call here, may not necessarily replace any of our more typical fertilizers as far as results if you're looking for a really, really green lawn or something, but it is going to add valuable nutrients and organic matter to the soil. If you're going with trees and shrubs, make sure you follow the proper process in the first place. For planting a tree, native soil, you want to keep as much of your native soil generally. However, you can mix equal portions of compost as well as that native soil to kind of give you a good mix, as well as hitting that newly planted tree with some good nutrients. And you can also add compost around trees and shrubs, probably not more than a foot beyond the drip line and about 2 feet from the trunk. Just like with mulch, do not pile compost in a volcano type manner around the base of your tree. That's going to create all sorts of other problems. In a more typical setting for compost in the garden, you can add it pretty much any time of year, but of course right now it's spring. You want to add those nutrients when they're going to be most used, when it's a good time to kind of renovate. So you're going to hit those plants with nutrients at the beginning of the growing season. You're going to add more microorganisms. You're going to help regulate your soil temperature, your actual water holding capacity, and your cation exchange. So the actual use of the nutrients in the soil, the ability of your soil to actually bind and take those nutrients in and provide them to your plants. That's the cation exchange, the simplest way to explain it. That process is going to be assisted by adding this good compost. And really, if you're like a lot of gardeners in our area, there's a lot of clay. And so as you add more and more good compost and natural, things like that, organic material, it's going to give you a more workable garden. It's going to reduce erosion if done properly, because there's actually good, soil to take in that water. And really, you're not adding any additional, artificial fertilizers or things, and it can save you money. You may find that compost is more than enough for you as a gardener. You may see the results in your fruiting vegetables and plants, things like that. And really, it's a fun activity for the family. Get out there, add the compost. It's one of those things that you can add to your gardening to-do list every year. So how much should you add? 1 inch per year is not a bad idea. That's the recommendation here. If you want to get down to the nitty gritty with math, about 8 or so cubic foot per 100 square feet of compost. If you're doing a large garden, 3 cubic yards per 1,000 square feet. Those are good ratios. If you're bagging it up, you can actually do some of those calculations on your own. And then before planting, like I said, that's a key time to do it. It's a great time to renovate your gardens, improve your composition. It doesn't mean you can't add it at other times, which would be what we call top dressing, where you're actually adding in those nutrients while the plant's maybe getting ready to fruit or whatever. One other way to add is to actually bury the compost before it's fully finished. I have not done this myself, but actually burying that compost about a foot down beneath the soil in the fall, that would be one method for, like I said, kind of renovating a garden and giving it a chance to break down within the natural soil layers and give your plants a good soil to thrive in. Getting close to the end here. So compost tea is a really popular way of utilizing the nutrients that you've built and developed, if you want to use that term, in your compost. Compost tea recipes are something that I get asked about a lot. I have not used compost tea. I have used compost quite a bit, but not compost tea. Compost tea essentially is taking the compost and, exactly as it sounds, creating a tea. You can use a burlap or cloth bag to put the compost in, using a 5-gallon bucket, dumping it in the water and letting it sit in that water for 1 to 3 days roughly, steeping it every now and not constantly, but a few times, steeping it like a tea bag or agitating it, and those nutrients are going to leach into that water, and you can actually put that water directly onto your plants, into your garden, and you can generally get maybe 2 or 3 uses out of that compost tea before you need to move on. But if you have a lot of compost, this is a great method for hitting those plants with good nutrients at just the right time. It has a lot of the same benefits, but some benefits you won't see as actually directly adding. Compost would be you're not really doing anything to benefit soil structure. The cation exchange capacity isn't improved because you're not actually improving the soil structure and whatnot. And then your water holding capacity of the soil, you're not going to see any benefit to that. So just to conclude, I really want to thank Simon for putting the presentation together. He's done a great job with this, and he's taught composting several times as well. But just in conclusion, nature does a lot of these things on their own already. Composting is a natural process that humans have adapted, just like plant breeding, and improved upon to, for our own benefits of eating vegetables and other plants, as well as using in landscapes and so on. Humans can help by speeding up the process. There's several methods, but use the method that works for you. Whether you're in an apartment gardening in buckets, or you're in a large farm gardening up to an acre of vegetables, use the method that works best for you in your circumstance. But make sure you're doing it right. Make sure you're adding the right inputs, following the peer-reviewed research process. If you ever have any additional questions about how to actually do composting properly, reach out to your county extension educator, and we're always happy to help. If you're watching the recording today, just get in touch with your local county office, whether you're in Indiana or not, and we'll be happy to help you. So with that, I want to once again thank my partner, Simon. But if we have a minute, anyone wants to hang around, we can try to answer a question or two.
If somebody has any questions for Simon or John, please either unmute or pop those in the chat box. We'd appreciate it.
I was just going to say, great job, both of you. Appreciate the information.
Yeah, I want to second that. Thank you so much for the information. I do want to ask, is there any way that the slides will be available?
Michelle, yeah, if you want the slides, I can send them to you. I don't know whether you saw my email address at the start, but just send me an email and I'll send them to you by email.
I will do.
Yeah, do you know my email address?
I can go back to that.
Okay, yeah, send me an email and I'll send them to you.
Perfect. Thank you so much.
Any other questions for John or Simon? Okay, gentlemen, I'm going to stop the recording then.